Hi everyone. Today we are going to study about the IoT protocols. How the IoT devices communicate with the network. It is through these IoT protocols that the IoT devices communicate with the network. IoT devices communicate using IoT protocols. Now, in a network, there are multiple IoT devices, but unless those devices are able to communicate with each other, there is no point having an IoT device. So, there needs to be communication among them in the network in which they are present. So, it is through these IoT protocols that the IoT devices communicate with each other in the network that they exist. Internet protocol, or IP in short, is a set of rules that dictates how data gets sent to the internet. So the first most important protocol, which you must have heard about earlier also if you've studied computer networks, is the internet protocol, or the IP as we commonly call it, and it is a set of rules. See, protocols is basically a set of rules and conventions that decide how communication will take place in a network. So for that reason, we require protocols for communication of IoT devices also, and these protocols are specific to the IoT technology, hence they are known as IoT protocols. So the first protocol that we talk of is the internet protocol, or IP, which is again a set of rules, because any protocol is a set of rules and conventions, and this protocol also, just like any other protocol, dictates how data gets sent to the internet. Because in a network, when devices are present and they need to communicate with each other, so the data would be first transferred through the network, which we commonly call the internet. So the data will first be sent to the network or the internet, and from there it will pass on to the device for which it is intended. So basically IP is doing this task of dictating or deciding how the data will be sent to the internet or the network. IoT protocols ensures that information from one device or sensor gets read and understood by another device. So in IoT protocols, there are not just devices, but there are sensors also which are involved. Either the sensors will be present independently or they'll be embedded inside the devices. So the devices are either communicating with another device or with a sensor, and these protocols made for IoT ensure that information which is being sent from one device or from a sensor gets read and understood by another device, a gateway, a service. So this information should be understood and read by a device also. Device, you know, is what? Gateway is basically a mechanism or an interface for communication between different networks. Within the same network, you do not require any such advanced technology as such. You just need to transfer the data from the device to the network, and then it goes on to the intended recipient. But when you are talking about different networks, that is intra-network communication, for that gateways are required. So if it is in the same network, then it should be understood by the device or sensor. If it is in the different network, then apart from the device or sensor, the information should also be read and understood by the gateway through which it will enter the different network, and from there it will go to the intended device. And it should also be read and understood by the service, which would be providing for the communication between different devices or sensors. Different IoT protocols have been designed and optimized for different scenarios and usage. See, you cannot use the same protocol for all the scenarios. For different scenarios or for different usage requirements, different IoT protocols are required. And for this very reason, different IoT protocols have been designed and then optimized for different scenarios and usage. Given the diverse array of IoT devices available, using the right protocol in the right context is important. because there is a diverse array that the IoT technology is serving. So for that reason, you have a diverse array of IoT devices available. And then it is important to choose the right protocol for the right IoT device, for the right scenario, and for the right kind of usage in the right context. This is very important. You cannot just pick any protocol and use it for any device or any scenario. You must choose the right protocol for the right kind of device and the right scenario. Now, this was just an introduction to IoT protocols and how important they are for IoT devices to communicate. But now let's look at these protocols in detail. These protocols are used to establish communication between a node device and a server over the internet. So basically, as we know that the protocols are used to establish communication between different devices. So here also in the IoT technology, the protocols are used to establish communication between a node or a device and the server over the internet. Every internet has a server, which is basically a database of information, and whenever you want to fetch any information, it is fetched through the server. The client sends a request to the server, and if the server has that data, it processes it and sends back as a reply to the client. The simple web browsers that you use are an example of client-server applications. When you sit on your laptop and you type the name of any website, say for example you type www.abc.com. Now through the server of that internet connection from your particular web browser, which is the client. Any web browser which you are using is the client application. When you type the name of a specific website on that client application, that is your web browser, the request goes to the server of that internet. Now if the server has that website available in its domain, in its database, the server will first of all look up for it. If it is found, it will process and then send back to it. So whenever you see the home page of any website whose web address you have typed in the URL, that is a result of the request processed by the server and sent back to the client. So basically all the that means it is a communication between the client and the server. So obviously these protocols are then used to establish communication between a node device and a server over the internet, because communication with the server over the internet is very important to get the reply of a request that you sent. Asking for a particular web page or a social media site is an example of that request and response scenario. It helps to send commands to an IoT device and receive data from an IoT device over the internet. Whenever we want some task done or whenever we want some response through the IoT devices, it is these protocols that are helping to send commands to an IoT device so that that particular IoT device knows what it has to do, what task it has to do, and then when that IoT device sends back the response, then it is these protocols are also important to receive data from that IoT device over the internet. So you send data to the IoT device and then you receive data from the IoT device, obviously over the internet, with the help of these IoT protocols. We use different types of protocols that are present on both the server and client side. So as I said, it is a client-server communication, and these protocols are not just present on one side, but they are present on both the sides, that is the server side also and the client side also. And these protocols are managed by different layers like application layer, transport layer, network layer, and link layer. Now let's look at these protocols through a diagram. So basically, as I said, these protocols are managed by different layers called the application layer, transport layer, network layer, and link layer. So we will understand through this diagram that this is the application layer and there are various protocols at the level of application layer. Then there is this transport layer and there are various protocols at the transport layer. Then there is the network layer and there are various protocols at the network layer, and then is the link layer and there are various protocols at the link layer. Now all these protocols are specific to these layers. That means these all protocols that you're seeing here are specific to application layer. Then the TCP and UDP protocol that you see here are specific to the transport layer, hence they are also called transport layer protocols. Then IPv4, IP version 6 and 6LoWPAN, these are network layer specific protocols. Similarly here you can see all these protocols are link layer specific protocols. So at every layer you have specific protocols and they are that layer's protocols. Now let's look at all these layers and their protocols in details. So we'll start with the top, that is the application layer protocols. So for the application layer protocol, in this layer, what are the protocols doing? They are defining how the data can be sent over the network with the lower layer protocols using the application interface. So basically all the protocols in general at the application layer are defining how the data will be sent over the network through the lower layer protocols, because usually the data passes on from the upper layer till the lower layer and like this. So the flow of data is from the upper layer to the lower layer, then from the layer lower to it, and so on until it reaches the network. So basically the protocols at application layer are doing this task, that is of deciding how the data will be sent over the network with the lower layer protocols which are using the application interface. So all the lower layer protocols, that means the protocols that are at the lower layers of the application layer, which is your transport layer protocols, network layer protocols, link layer protocols, they'll all use the application interface of the application layer. These protocols of the application layer are HTTP, WebSocket, XMPP, MQTT, DDS and AMQP protocols. Now we will study all these application layer protocols in detail. We'll start with HTTP. HTTP you must have studied earlier also if you have studied web designing. So the full form of HTTP is Hypertext Transfer Protocol. It is a protocol that is present in an application layer for transmitting media documents. As the name says, it is the Hypertext Transfer Protocol. So what task is it doing in the application layer? In the application layer, it is transferring or transmitting various media documents. It is used to communicate between web browsers and web servers. So the communication between the web browser and the web server that I was talking of takes place through this very protocol, which is your Hypertext Transfer Protocol. So when I said that a client makes a request to the server for a particular web page or a website, it is through this HTTP protocol that this request is made by the client to the server. So this protocol makes a request to a server and then waits till it receives a response, and in between the request server does not keep any data between two requests. So that is why, for this very reason, you must have seen that whenever you type any website's name, by default HTTP is written in the URL, in the URL of the address bar. This is the address bar of any web browser, and in this address bar, if you type www.abc.com, then even if you don't type HTTP, it comes by default in the URL of this address bar, because it is this very protocol which will be sending the request from your side, that is from the client side to the server, for this particular website that you are asking for, right? So this is the protocol that is doing this task of displaying that particular website on your home screen. So whenever you see any social media site or any website on your home screen, just remember from now that it is the HTTP which did this task for you. It sent the request from your side, that is the client side, to the server, and then the server responded to that request and sent you back that web page or website that you are now seeing on your screen. The next protocol of the application layer is the web socket. Now this protocol enables two-way communication between a client and a host that can be run on an untrusted code in a control environment. So basically, as I said, in a network, it is very important to have two-way communication. It is not necessary that only one party will send the data and only one party will receive the data. Many a times the scenario is like this, that one host will both send and receive data and the other host will also both send and receive data. So communication is mostly two-way in any network. So this is that particular protocol which is responsible for enabling two-way communication between a client and a host that can be run even on an untrusted code in a very controlled environment. This protocol is commonly used by web browsers. So any web browser that you use, I won't name them, but you know what all web browsers you use, so that they are, most of the web browsers that you are using this protocol, which is the web socket, that is enabling a two-way communication between your device and the client software. Then the other protocol, application layer protocol, is your XMPP. The full form of XMPP protocol is Extensible Messaging Presence Protocol. Now, what is this Extensible Messaging Presence Protocol? This protocol is used for streaming XML elements. If you have studied web designing, you know what XML elements are. Basically, the full form of XML is Extensible Messages Presence Protocol. So Extensible Messages Presence Protocol over a network in order to exchange messages and presence information in close to real time. So whenever any real time communication, in a summary, whenever any real time communication is required, it is with the help of this very protocol XMPP that a real time communication or information exchange takes place. Mostly used by instant messaging applications like WhatsApp. As I said, it is required for communication in real time, and WhatsApp is a very good example of real time communication, wherein you want that the moment you send a message, it is received by the receiver, not even a few seconds later. So it is used by these kind of instant messaging applications like WhatsApp. Now let's see what XMPP actually stands for. When we elaborate the term XMPP protocol, X here means extensible. It is an open source project which can be changed or extended according to need. So X here means extensible, that means it can be extended, and it is an open source project. When I say open source, that means any application that is willing to connect to it can connect to it. No permission is required to connect to it. So it is an open source project which can be changed or extended according to the need of that specific application. So this is what extensible, X of extensible means here. Then we talk of M. M means designed for sending messages in real time. M here means that it is designed for sending messages in real time. Like I said, you can instantly send messages over WhatsApp. Then P here determines whether you are online, offline, busy, or in a presence state. Okay? So basically, with the help of P here is determining, through these messaging apps, you can determine whether a person is online, or that person is offline, or that person is busy. Then the last P of XMPP basically tells you that it's a protocol, that means a set of standards that allows systems to communicate with each other. This P here stands for protocol, and that means a set of standards, and which are basically allowing you to do what? They are allowing various systems to communicate with each other. So this is what the XMPP of the XMPP protocol means, and it is basically used for real-time messaging. Then is your okay, as I said that XMPP is a protocol used for streaming XML elements. Now we'll go into the details of what XML elements are. You must be all curious about what these XML elements are actually. So talking of XML elements, your XML first of all stands for Extensible Markup Language. If you have studied web designing, you must have studied XML also. So the full form of XML is Extensible Markup Languages. And these languages have various sender information, receiver information. It has a heading. It has a message body. I will show you through an example. This is an example of an XML language. So it has the sender information. Through this note, you get to know who is the sender of this message. It has the receiver information, and through this tag, as you can see, this delimiter, through this you can have the receiver information. So it has the sender information, it has the receiver information, and the sender information in the to delimiter, the receiver information in the from delimiter. It has a heading. Any heading you can give over here. In the note you can give heading so that the person gets to know that what that particular message is all about. Just like in the email you have a subject field wherein you tell the receiver about the subject about which this mail is. So here also note acts as serves that purpose. It is a kind of heading. The to delimiter tells you who the sender is. Sorry, the to delimiter tells you who the receiver is, and the from delimiter tells you who the sender is. Say for example, Janvi is written here, so from this from delimiter it will be known that this sender is a person named Janvi. Then it has a heading section or a heading delimiter. Heading basically tells you the topic about that particular message, what that message is intended about. So if it is a reminder, say for example, so this is a message from Janvi to Tove about the reminder of a specific thing, and then it has a message body. So this is the message body that I was talking about, which is within the body delimiter. So the message body says that let's meet this weekend. So, and then the note finishes. So basically a note in the XML message, then the to section which tells you about the receiver of the message, from section which tells you about the sender of the message, heading section which gives you an overview about this about what this message is about, and the body section, message body section, which gives you the actual message. So the output would be somewhat like this. This is the format in which you write this XML message. It starts with a note, then the to delimiter which will tell who this message is intended for, then the from delimiter which will tell from which person this message has come from, then the heading delimiter which tells or gives a brief about the message, then the message body which gives you the actual message, and then you end the note delimiter. Now the output would be somewhat like this. The output of the message when it is run in the browser would be like to Tove. Now the other application layer protocol is your Advanced Message Queuing Protocol, also known as AMQP. This is basically a software layer that creates interoperability between messaging middleware. Whatever are the middleware applications or softwares of messaging, it creates interoperability between those middlewares. It helps a range of systems and applications work together, creating standardized messaging on an industrial scale. Then is the Constraint Application Protocol, also known as CoAP. A constrained bandwidth and constrained network protocol designed for devices with limited capacity to connect in machine-to-machine communication. So basically, as the name says, constrained application protocol. So it is designed for those scenarios wherein there is limited or constrained bandwidth and limited or constrained network, and then it is designed for communication among those devices which are in a network which has a very constrained bandwidth and a constrained network. CoAP is also a document transfer protocol that runs over user datagram protocol. It is also used for transferring the documents, hence known as the document transfer protocol, and it again runs over another protocol which is the user datagram protocol, or UDP in short. Then is the data distribution service protocol of the application layer. This data distribution protocol or data distribution service is a versatile peer-to-peer communication protocol that does everything from running tiny devices to connecting high performance networks. So it is very versatile protocol, versatile in the sense that it is not specific to a particular kind of network or particular kind of device. It basically helps in communication between even the tiniest of devices and to connecting to even the highest performance networks. The data distribution service or the DDS protocol streamlines deployment, increases reliability and reduces complexity. So these are some of the advantages of using a data distribution service or DDS protocol. Next protocol of the application layer is the message queue telemetry transport or MQTT protocol. This is a messaging protocol designed for lightweight machine-to-machine communication and primarily used for low bandwidth connections to remote locations. So basically, whenever there are lightweight machine-to-machine communication, not a large amount of data is not being sent, a very small amount of data is being sent. So for that reason we called it a lightweight machine-to-machine communication, and it is primarily used for low bandwidth connections. That is why we specified lightweight communication, because when there is low bandwidth, it is not possible to send very large amounts of or large chunks of data. So for that reason, for lightweight communications from machine to machine, in the scenarios when there is a low bandwidth connection, especially to the remote locations, the protocol that is used is your message queue telemetry transport protocol, also known as MQTT. MQTT uses a publisher-subscriber pattern and is ideal for small devices that require efficient bandwidth and battery use. So basically, the pattern that is used by MQTT is a publisher-subscriber pattern, and it is ideal for small devices, such devices which require efficient bandwidth and battery usage. Now, what is the publisher-subscriber pattern? Basically, when we talk of publisher-subscriber pattern, publisher is your sender of messages. Publisher is the sender of the messages, and publishers do not send data directly to specific receivers. The publishers are the senders and the subscribers are the receivers. So the publishers will not send data directly to the subscribers. Messages are categorized into classes. The messages or the data that will be sent by a publisher will be classified into different classes, and without the publisher knowing which subscriber may have subscribed it. So it is just like the when you subscribe to certain newsletters. So the newsletters, the websites of those newsletters or the newsletters are the publishers, and whosoever subscribes to those newsletters, those data, and that too in the category of these subscriptions, like you may have subscribed to some home decor category, somebody else must have subscribed to the technology category. So the data from that particular newsletter, which is the publisher, is categorized into different categories, and then as per the and according to which category as a subscriber you have subscribed to, you will receive you'll be updated and receiving daily messages or weekly messages from those newsletters as and when they are published. And those newsletters don't even know who all are receiving those messages as subscribers. So they are not directly from publisher to subscriber, but they are in that particular website only. And from there you get notifications that today you have got an update about this home decor thing, or today you've got an update about this technology thing. So it is from the publisher to the subscriber, that is sender to the receiver, and it is not direct from the publisher to the subscriber. And the publisher messages from the publisher are categorized into different classes, and according to which class of the message the subscriber has subscribed, he will keep receiving those messages, and the publisher is not even aware of who all these messages or which subscribers these messages are going to. And these messages will go only to those people who have subscribed them. So now we are done with all the protocols of the application layer. We have covered HTTP, we have covered CoAP, we have covered WebSockets, we have covered MQTT, XMPP, DDS and AMQP. In the next video, we are going to study the transport layer protocols, which are TCP and UDP.